Actually, I started by sewing this. This piece in half. Because the length of that piece determines the length of the bearing housing also. And what's gonna be fun is that I think I'm gonna finish this shaft when it's welded to the long pipes, which means that I'm gonna have a 2.7 meter long piece in the lathe, which is almost the maximum capacity. But I'll have to think some more about that, if it's possible to machine it first and then weld it. It would be perfectly straight if I turned it after welding, but we will see. Okay, I did some more crude drawings. So this will be the bearing holder, bearing housing. And this is the part that I'm gonna machine first. At least I'm gonna rough it first. So this is the part that I'm doing now, and this is the middle part of the thick wall tubing. So it's gonna have its inner walls like this. So, and it's gonna be this way. So this is down and this is up. So, and of course the shaft is going through like this in here. So I decided to put the deep groove ball bearing here in the bottom, and on top of it will be the thrust bearing, and that's so that I can get the most distance between the ball bearings, so there will be as little stress on them as possible. So the ball bearing will be 95 millimeters in outside diameter, and the thrust bearing will be 85 millimeters. And the thrust bearing will rest on the piece of pipe that I'm gonna weld to this piece. So it's gonna get support in this area right here and here, and then it's gonna contact the inner race of the ball bearing in here. And I think I'm gonna have to make some kind of piece to transfer the weight, I mean the force from the lower part of the bearing to the inner race of the ball bearing. Too bad I don't still have the bearings, but they should be here in a couple of days. So first let's rough this out, and then we're gonna weld it to this piece, and then when both sides are welded on, I will do the finish machining. Okay, it's kind of sad to put this beautiful shiny tool holder to action and make it dirty, but that's why I bought it, so I guess that's what I'm gonna have to do. Here it goes. And I think in time I will update all of my tools. Well, the majority of my tools to use this kind of insert, so that I only have to buy one kind of it. But I don't have a single boring bar that uses this insert, so that's something I'm gonna have to get. Okay, let's see how it cuts. First let's choose the cutting data. we are cutting steel, so we read here we should be running 150 meters per minute, and the suggested feed is 30 hundredths and DOC is 3. So first I'm gonna clean the face right here. It's pretty inaccurate at the moment, and you can see the piece is hanging out quite far from the chuck jaws, so I don't want to be too aggressive, but it says AP is from 0.75 millimeters, so I guess I'm gonna try like 2 millimeters first, or maybe even 1.5, and see how it works. But first let me calculate the correct cutting speed. Okay, so when the cutting speed is 100 meters per minute, the diameter of the workpiece is 115 millimeters, the speed would be 415, and the closest to that I have is 360, so we're gonna use that. And I think I'm gonna choose a feed of point, let's see, feed will be 0.22 millimeters per minute, millimeters per revolution. Okay, let's start cutting. As you can see, it's wobbling very nice. So let's dial in 1.5 millimeters. Okay, let's see how it goes. Two millimeters. Really nice work. Beautiful finish. Nice chips. Very nice. Again, I have no idea what kind of a material this is. Okay, let's take another 2 millimeters. Let's go with one first. I don't know, I don't want to waste this material. Okay, need to take one more. And still one more. Okay, there's a little spot which didn't clean up, but that's okay. Very, very fine finish. Beautiful. Okay, now moving for the outside surface. And the feeding speed is 0.28 millimeters per revolution, so it's a little bit more than with the last cut. And again, I'm gonna remove only as much as I need to clean the workpiece. So let's start with maybe 1 millimeter. I got the wrong feed, sorry. It was only feeding half what I thought. Now it's full feed. Very nice. And the tip breaker is doing a great job. Looking pretty good. So, now let's think what to do next. Okay, for now I think I'm just gonna clean the inside and then I'm gonna cut this piece in 4 40mm long pieces. Okay, let's do the cleaning. Okay, feed is now 1600 per revolution and the speed is the same. Starting with 1 millimeter. Another. It's ringing pretty bad. Try some more feed. Not quite cleaning, let's take half a millimeter more. enough now. Okay, now ready to part off the first piece. And by the way, this tool always likes to ring. I think it might be because of this boring bar is a cheap one. It's made in China. I'm thinking so. Okay, now ready to part off the first piece. I'm using this Sandvik Coromantec Q-Cut blade, which has taken a pretty bad beating. Maybe you can see, but the tip here is actually bent, and that's why I have to set the tool a little bit in an angle so that it's cutting straight. And also the tool holder right here behind the bit is also very worn, but I have still had some success with this, so let's see how we do this time. I'm still gonna lower the speeds. I'm gonna try 180 RPM, which is pretty slow. And for feed I'm gonna try 11 hundredths per revolution. And maybe I will add some cutting oil also. Okay, let's see how we do. Not too bad for a worn out tool, I think. Not too bad. Now let's take another one. I think I'm gonna use the same speeds and feeds. see how much we still have. We have enough. So I said wrong. We're taking 2 pieces with 45mm length and 2 pieces of 25mm length, because the upside only has 1 bearing and the lower side has 2. Okay, now let's continue. And also my cutting oil is making a lot of smoke. Actually, it's just plain oil. I wonder if I should try a little bit more speed to break the chips. Okay. And you may have noticed that I was a little bit too much in a hurry, so I forgot to continue cleaning the boards. But luckily there's still 15mm of clean surface that I can indicate from if needed. So next I'm gonna clean the rest of the piece. I mean the inside with a boring board. Okay, that's enough. Very nice shiny finish, though it's ringing a little bit. On the camera you can see that it's not, it has a little bit of chatter, but it still looks beautifully shiny. Let's switch to parting tool again. Okay, same speed, but I'm gonna increase the feed just a little bit. It's now 1400 per revolution. Let's try it out. I hope it can take the load. At least it's not breaking the chip any better. Okay, let's try less feed this time. Now it's only 0.09 millimeters per revolution. Let's go. Not braking. Let's go back to the 1100s. Holy smoke. Okay, nothing to write home about, as one of my great idols would say. But it worked. Now let's go to the smaller lathe. Okay, this is my setup for the small lathe. So I'm holding the pieces on the inside in the 3-jaw chuck. And this is the one that I almost messed up, but you can still see there's like 2 millimeters of space between the rough part and the jaw, so it will center just fine. And what I'm gonna do, I'm gonna use this boring bar to bring the inside diameter to 85 millimeters and about 5 millimeters long. So let's get set up. Okay, we are set up now. I have centered to the edge right here, and the speed is 400 RPM, and the feeding speed, let's see, feeding speed is 15 counters per revolution. Okay, let's do a slight cleanup first so we see where we are, because this surface is still so rough. Glacis. Okay, let's see where we are. Still didn't clean all the way. Exactly 80. So 5 millimeters to take off. Should be 1.5 millimeters to go. Let's see. Little bit less, it's 1.2. So let's take a full millimeter and then a finishing pass. Okay, 3/10 to go, and I want to go a little bit over. So let's do 3. Okay, should be a little bit over now. Yeah, it's a 10th over, that's fine. Too bad I can't relieve these corners, I'll have to do it later.